Hey guys, I'm going to run you through some of these quest problems real quick. This is the way, I'm going to skip this one for right now, because this is kind of like a tricky one. It's really not that bad, but we'll look at it in just a second. Alright, let's get going right away. I'm going to show you like a little shortcut for this one. Which of the following combination resistors? So which resistors? So we're looking at the resistor, we're looking for what resistance, right? Would dissipate or use up 1200 watts, which is a unit of power, when connected to 120 volt power supply. So this is your voltage, right? All right, so what are our givens here? We have P and we also have V. Our unknown is the resistance. What equation has P, V, and R? None of them, right? We have P equals IV, and we have which law has R in it? We have Ohm's law, right? V over R, right? But we don't have something that gets us R directly. So let's see if I can do a little bit of magic here. Can I? Let's see, if I it's just solve for my current, right, by dividing by V on both sides, we wind up with P over V equals I. And check this out. Since this is equal to I, and there's an I here, guess what I can do? I can take this guy and plug him in right here, right? So P over V equals V over R, and guess what I have here? A couple of fractions I can cross multiply. So basically, you end up with an equation. This is another equation for energy. This is kind of a derived one that some of your CCA kids might already know. This is V squared equals P times R, and so you could solve for power by dividing by R on both sides. So power is equal to V squared over R, right? But in this case, we're solving for R, so let's go ahead and divide by P. Okay, good. So the equation we're going to use is this guy right here. Okay, now, so whatever answer you get from plugging values in here is going to be the number of ohms you need for the problem. So what you're going to go through is go through each one of your answer choices and see if you can figure out the equivalent resistance for each one of the answer choices, right? So go ahead and take a look at that, all right? So the equation, again, you're going to use to figure out resistance is this guy. V squared over P equals your resistance. Remember, that comes from this equation. Power equals V squared over R. So this is another way to use that, and all I did was switch the extremes and the means, right? Okay, let's go down here. Okay, 18 ohm, 13 ohm, and 9 ohm are connected in parallel to some source. I'm going to draw that right away. So let's go ahead and draw that. For all these problems, you should draw them so that way you know what they look like. Otherwise, they're going to be tough. All right. Okay, so you have 18 ohms here, 13 ohms here, and you have 9 ohms here. Okay, now, really good, important piece of information they give you is that 6 amps is running through the 13 ohm resistor. Okay, so I'm going to represent that as an arrow going through, putting 6 amps there. Okay, calculate the equivalent resistance of the circuit, and what is the rule that we know about for collapsing this circuit and making it into equivalent resistance? Okay, so just think about that, right? All you're going to do is your sum of the reciprocals and flip that, right? Now let's go on to the fourth part. What is the potential difference? What is the other word for potential difference? That's voltage across the source. So the source was right here. So looking for that. Now you don't have this. Usually you're given the battery voltage, but you don't have it, right? But since this is parallel, what's the special rule you know about parallel circuits? Which one of the variables is constant? Is it I total equal to I1, I2? Is that it? No, this was for series, right? Because the same amount of water runs through every pipe, just like right here, right? So if 1.1 amp of current's running through, I drop it in, it's got to go through here, 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 right? So that's not it. It was the voltage is constant, right? So guess what? The voltage is equal to C for parallel circuits, right? So let's look here. Is there anywhere that I can find the voltage across any one of these branches here? We'll look here. I got 18 ohms. What else? Nothing, right? So I don't have enough to use Ohm's law. What about here? I got 9 ohms. Do I have current or resistance? No. I don't have current or voltage there. But if you look at this guy, you're given the resistance and the current. So guess what you can solve for? You can solve for the voltage that way, right? If you just get rid of R. And whatever this voltage at resistor 2 is going to be, guess what? It's going to be equal to resistor voltage at 1. It's going to be equal to the voltage at 3, which is going to be equal to the voltage source, right? The total. Let's move on. Okay, consider the following circuit. First of all, Is this a series or parallel I'm looking at? Well, am I able to get through any of these resistors and directly back to the source without touching anything else? If you can't, then guess what? You have to pass through every single thing in a series, right? That's why we call it a series circuit. All right. So what is the potential difference? What's the other word for potential difference we have? That's voltage across the 1 ohm resistor. Okay, so this is your resistance, right? So what's the rule that we just talked about for series circuits? Remember, if I drop a cup of water in this pipe here, if it was a water pipe, if I dropped 1.1 gallon, there's no way that this 1.1 gallon could make it all the way back without passing through each one of the bends of the pipe, right? So guess what they all share? They all share the same current. So your givens for each section of this problem is going to include this 1.1 amp current. All right. So let's see the potential difference across the 1 ohm amp. So what do I have? My givens are resistance and, of course, current, because the current total is equal to the current everywhere. Unknown is the potential difference or voltage. Equation is just going to be Ohm's law. I equals V over R. You just solve for V. Okay. And then potential difference across the 6 ohm, it's the exact same thing, right? So here's the 6 ohm. You're given R, you're given I, you can solve for V. Cool, cool, cool. All right, let's go back up here. Basically, every single one of the other problems I'm not going over right now is some derivation of these skills here. Okay, you're either going to break down some sort of combination circuit like we went over in class today. I'll show you an example of that right now. This is kind of a tricky guy right here. What you need to think about with this one is what does your water flow do as you pass through here. So we start out with a lot of water here, and a bunch of it's going to break off and go this way. The rest of it's going to go here, right? And then as it hits this junction, it breaks off, goes this way. Okay, and it becomes like a series circuit at each section, right? So these 3 guys are acting in series. They recombine here, right? And then these guys here are going to all combine here, right? So because we kind of have a nice little messed up combination of series and parallel, what you have to do is kind of work from the right and move inward, right? So these 3 right here, you're going to add up. You're going to break it down, right? And I'll show you kind of at least the first step. So remember, if you don't work all the steps out, you're not going to be able to work some of the more complicated problems, right? So let's see, we got 7, 14, 36, and what would happen if you added up these 3? You end up with 88, and in the middle, 33. Well, now look at this. These 2 are now parallel, so guess what? You can combine these right here by doing 1 over the reciprocal, right?
Can I just come into one of the things?
You take it out.
Well, it's just that now I have to add.
Yeah, that's fine. All right. So let's see. So you're going to break these down by combining the circuits. So 1 over 88 plus 1 over 33. And then you flip that answer. You end up with, did I get that right? 6 plus 1 plus 41. It is 88. Yeah, you get 24. Yeah. Make sure I punch the wrong thing into the calculator. That's always fun. All right. Okay, then what do you have left after that? You have to write in whatever you have left. You got 7, you have 14, and you have 36, and then you'd have to start it over from there. Okay. So this is going to act as a series, and then you can combine these as a parallel. All right, I hope that helped. Good luck.